Hello, everybody. Chloethedev here. Welcome to Chloethedev Unfiltered. I'm going to be doing a stream where I'm going to be watching Near 102. I did a stream yesterday where I was just getting started as if I was a new developer getting into Near, and I got stuck very early on. So I'm actually going to show where I got stuck. Let's go near dev. No, it was docs. So I was popping in here, and when you get into develop, uh, or maybe it's the near CLI, yeah. And when I was downloading it, what I had an issue is it said setup, installation, okay. So I had, I installed npm, I made sure it was good. I had Node 12 or above, and then I got to step 3, and it said install near CLI globally by running this command. Did that, couldn't get it to run. So I kept going, couldn't get it to run, couldn't get it to run. I tried a bunch of different things, I Googled things, and I knew it had to do with my path. I'm not very good with resetting my path. I usually use Linux and like npm. It seems to always just do it for you, or whatever. I never have to worry about my path in Linux before. And Debian, I've always used that with my Google devices. But I knew I was going to path. So I was talking to people when I was learning about it last night, and I was like, I knew kind of what I had to do. But when you go to Windows, so I just skipped this. I saw Windows and I just skipped this. But if you see here, this is the answer. Change the npm directory. Click here. This is how you get it done. So if you're on Mac and you have the issue, I'm actually going to take this and add this to my my old video from yesterday, so people can see what you have to do. But literally, you just copy and paste these directions. You can do this instead of steps 2 to 4. Whatever, if you don't want it, whatever you want, doesn't really matter. The point is, this is the answer of how to do it. It works on Mac. No issues there. So yeah, sorry. And this was a video I'm going to watch later on. I had a meeting actually with Sharif this morning, and I actually, because of the issue I had yesterday, I was like, "Oh, Sharif, it'd be great to have a meeting with you." And so he's like, "Oh, sure, let's have a meeting." And it's funny, the minute before the meeting started, I saw that little link. Actually, did I just close the link? That's hilarious. I would do that. 1 second. Let's open that back up. So I found this link a minute before my meeting, and so the meeting was mostly about what he was doing with education, no programs at Near, and it was really fun. I really enjoyed the meeting. So, but now I'm going to be he recommended watching this video. It's a video basically for Ethereum developers who are getting into Near, and just this is the video to watch to get started. So I'm not going to waste too much more time. I've already taken up 3 minutes. So I'm just going to get in now. It's about an hour, 53-minute video. Hopefully, I'm not going to pause it too often. I will add some commentary if I see that stuff. It is a workshop, so I could. Ooh, you know what? I might do this live as I go through it, because 1 second. I wasn't planning on actually doing anything live, but let's see. I have a terminal right here. If I can position it well, let's see. I might try and just code along. Let's see. There, that looks pretty good. A little more. And I think that's going to be all right. Okay, let's see if we can code along. I have near CLI. I don't know if I have a testnet account, so I might want to try and do that. I'm going to do this first. Oops. It keeps wanting me to... you know what? Fine. I wasn't going to do all these setups. But right now what I'm doing is I'm logging into Near. So I have a Near account already on my ledger. And I do want to, for now, keep everything, on my ledger. So pending review, so you might see that. It's normal. Enter the name of the account you're signing into. Chloethedev.near. Use Near Wallet to view accounts. Interesting. Chloethedev. Maybe I don't have an account like that. Can I just not do it? Oh, there. Okay. Sorry, this is weird. User not found. Oh. Oh, yeah. Yeah, I'm connected. I don't know why it's trying to get me to do this. This is very weird. Enter it here if not redirected. Okay. Please authorize at least one account at the URL above. Which account did you authorize? See, this is where it's funny because now I have to get through all of this. Okay. Let's see. Where was that thing that popped up? Did I close it already? Okay, let's see the near wallet. See, Chloethedev.near. I don't know any other accounts that I have. Let's look at my profile. Yeah, that's all it says, Chloethedev.near. Maybe if I copy and paste it. What if I don't near login? Okay, so it wants me to log in. Import existing account. I have a ledger. Sign in. Confirm public key. I see it on my device. Approve. User not found. But it says this is for the test net, and my user is on the main net. So maybe I haven't even created anything on the test net. So maybe I can hit add account. Honestly, okay, so test net. Oh, never mind. Okay, let's go sign in with Ledger. Okay, let's try this again. Let's see, I think I got it this time. Okay, it opens this. I'm gonna say create new account. Okay. Ha ha ha. See? It's because it's a test net. And I am still using my ledger for this because I want to test out how it's on my ledger. So my bad, but again, this is. So I had an account on mainnet, but I did not have an account on the testnet. And I think this will give me 10 near tokens as well. There's also the WIP at 3, so I only have 3 hours to do this, but 500 near tokens. Okay, so now I understand. This is mainnet, this is testnet. Okay, let's get going. I should be good to go now. Oops. Oh, they want me to enter it now, right? Enter it here. Chloethedev.near. The account you provided does not exist. Let's try it again. Okay. Allow. Sorry. Chloethedev.near. Confirm. What? Enter your account ID below. Oh, .testnet, sorry. Confirm. Okay. Now I need to add the key on my ledger, whatever. It's testnet, so who cares? Mainnet, I would probably read a lot more about what's going on. You were logging in. Please close this window. Okay, what happened in my terminal? Okay, which account did you authorize for use with Near? Chloethedev testnet with public key successful. Okay, so right now, whatever I was doing yesterday, putting up a NFT project onto testnet, I could do it now with the Near CLI commands. But we're just gonna start.
And I'm not going to keep the chat open because it takes up a lot of real estate here in the slides. So if you want to watch a recording of this, there's a couple of them at these links at the top.
Let's see. There you go. I'm going to try and keep my terminal open.
So what that means is if something doesn't make sense, or more likely, if you know something about what I'm saying, maybe.
And if I can see my chat, so if you pop into this video, you want to know what's going on, feel free to ask a question or whatnot.
Don't hesitate. I think that's really the best way to make this work. So I guess the fastest way to do that is just to kind of type something in the chat, and then have there be your voice.
Okay, so this is my got my Near, so
we've got about an hour together. I'll do my best to make sure this hour is useful for you. And
I might speed it up a bit too. So actually,
so this workshop is intended.
Here we go.
If it works, to be an intro to Near protocol for Ethereum developers. I myself am not an Ethereum developer, so I'm taking a big risk by claiming that I can actually make a workshop that's an intro for Ethereum devs. So you'll see along the way kind of where I've done it to learn about the Ethereum ecosystem and building on Ethereum. Here on the first slide, again, you'll find the recordings at the top right, a couple of install steps. If you've never installed Node on your computer, then I wouldn't do that now.
Let's see.
But if you haven't, you can install it in your CLI, the command line interface.
Okay, 15.0.1.
Perfect. So, why Near? That's probably your first question. So here's why Near is cheaper, faster, and easier to use. That's okay. I'm going to do my best not to read off the slides, but I'll talk kind of around and about them. When you're building contracts,
and I'll do my best not to interrupt.
So those are the two languages that you use to build contracts.
But I will.
Then you compile to WebAssembly, and then you deploy to Near. And that's different from Ethereum. You use Solidity typically. I guess there's a language like I don't know how popular that is, but you use Solidity, and then you would compile that to whatever the EVM bytecode is that it expects, and then you would deploy that to the EVM. So with Near, you're building on languages that have these communities that are not necessarily specific to blockchain. So Rust, obviously, is a high-performance systems programming language, a lot of type safety, rich tool chain, huge community. The Rust WASM connection is really tight. It's maybe the most mature WASM compiler out there. And so if you're dealing with high-value contracts...
This is all new information for me, too. So
you want to use Rust. So a contract that's going to be dealing with a lot of value.
Learning.
But AssemblyScript is familiar to JavaScript and TypeScript developers. In fact, it's a strict subset of TypeScript. So if you are familiar with front-end dev, then AssemblyScript is just a snap and pick up. It's really easy. And the mental models in Near don't change across these two languages. So if you're coming from JavaScript or TypeScript, you want to get started right away, dive into building contracts with AssemblyScript, figure out how Near works, and then if you want to learn Rust, you can go.
So they're saying, but I did see online that the security for the AssemblyScript isn't as high yet. Not sure, or for financial contracts.
Then go for Rust right off the bat. Nothing wrong with that. Okay, so that's kind of the high-level story in terms of development.
I'm not
and the argument there is that if you draw more devs, the learning and development, troubleshooting, debugging process is faster and easier to use because of the maturity of these tools. In production, gas fees are designed to be lower, so orders of magnitude lower than those of Ethereum, just out of the box from like primitive level operations. And obviously those can be changed through governance processes, but at Genesis on mainnet testnet, they're super low. There's also these mechanisms where contracts can earn fees. They get
this seems interesting.
At Genesis, they were set up as 30% of the transaction fees go to the contract itself or allocated to the contract account, which means developers have a mechanism for revenue collection that's baked into the protocol. And so that lowers your total cost of ownership of contracts, obviously, and some other benefits there. In terms of kind of being snappy, we're talking about like 1 second block time, 3 second finality, which is significantly faster than Ethereum.
3 second finality.
What you think about Near is it's cheaper, faster, and easier to use. Okay, and obviously,
Wow.
Ethereum and the Ethereum network, and the Ethereum community is where it's at, it's where it's been, and where it will likely be in the future. And so I think the argument here is really that we'd like to play with and alongside these applications, and you'll see a bridge in a minute here where we're talking about.
Very interesting.
One. Two questions. Yep. Just what laws of interpreter do Near and Hines use, and what aspects of the Rust toolchain speed up development?
So I think we use Wasmer, and I think Wasmer, Wasmtime, and there's another one maybe, but I think it's Wasmer is the short answer to that. And if you want to dig into that, I'm happy to connect you with the devs. But if you go to near.chat, you'll jump into our Discord, and you can ask there, and devs on the core dev team will be able to respond with more detail. I think the short answer is Wasmer. In terms of the Rust toolchain to make things faster and cheaper to build with, in general, when you're building software, I don't come off as like a know-it-all. I'm trying to answer your question here, so let me see if I can do it justice. When you're building software, like a big part of the cost of development comes from the maturity of the tools that you're using. So if you're building against like an esoteric language or a custom build language or a language that has sort of an isolated community, then typically there's going to be rough edges in the tools, testing, debugging. The kind of the development, testing, debug cycle itself is going to be a little bit slower. Setting up a test environment, setting up a dev environment, all those things are going to be a little bit rougher on the edges compared with an environment where there's a large community of developers that are innovating for many different target environments. And so whether you're building on a Mac or Windows or Linux or whatever, you should have a smooth experience. Basically, the more mature the language of the community and the tools that they use are. So hopefully that answers the question in general. Any kind of custom language is going to be a little bit rougher on the edges compared to the general purpose language. So that's the argument. I'll just keep going. If there's more follow-up, maybe you can just kind of direct me again. Awesome, that's okay. All right, so several examples and starters. If you go to near.dev, you'll see maybe 12 or 15 examples. Some of them are written in Rust and AssemblyScript. And basically, you can go in, you can check out the source code. Everything I'm talking about, including your protocols, all open source. So you can check out any part of any of these tools or systems that I'm talking about here. The examples on near.dev, you can actually run right in GitLab, which is
Okay, this is cool though. Status message. So I can send. I want to do. So I'm getting a new Google Pixel 5 soon, and I'm gonna use this as like a tester phone for like status NIM stuff. But that seems really cool. Sending status messages, creating a little status bot. That might be a project I get to. We'll see.
And we call them something a little bit differently on here, but you'll be able to read more about that. So anyway, these are examples you can just kind of get started with, and you can actually get started building a new app in just a couple of minutes. So if you want to start typing like now and see something work in the next 30 to 60 seconds, npx create-near-app, and whatever your app name is.
Okay.
And just npm contract by default with a plain JavaScript front end by default. You switch that to Rust or React, but I would recommend against that because with Rust you're going to need a little bit more tooling to do your development. Compilation process is a little bit slower.
Let's just see what happens.
Super fast. And then if you're not familiar with React, obviously that's going to add overhead to your learning process. So just like plain JavaScript is the simplest code you can find there. So npx create-near-app, and whatever your app name is, it'll generate a folder, build the thing.
I'm just going to download it in here.
npm run dev will create an account, deploy this app to testnet for you, and it'll load on your
npm run dev.
If anybody's curious, just shout out in the comments.
Okay, let's see. npm run dev.
So in general, same,
cool.
but different. We're talking about Ethereum. So
my computer's not the fastest, so give me some time.
And here I just picked a few things. So account, state, transactions, counts, and blocks. With accounts, you're talking about on Ethereum 2 kinds of accounts, is my understanding. So externally owned accounts and then contract accounts. And there's some things you have to know.
Let's see.
Ethereum, like externally owned accounts, are basically the last 20 bytes of maybe the implicit key generated from the
Sports one account type.
Or something like that. I'm getting that wrong. And like the externally owned accounts generate new.
Oh, CD into banana.
Key pair that are controlled by the contract. So there's some like specific constraints on accounts and what you do with these accounts. That makes perfect sense once you get it. With Near, it's basically just one kind of account. You may or may not deploy a contract to that account, and it's fine whether you do or don't. The account holds its own state, can have many keys.
Install dependencies.
Per And so
It's working pretty well so far.
You'll notice that like nonces are kept on the keys, not on the account. For example,
so it's deploying.
So with state
App crash. Waiting for file changes before starting.
With near
Oh, mainnet was
shard is on your account. Mainnet is currently only running one shard. Near testnet is running one shard. We have a guild called the Sharding Guild, a group of people who are dedicated.
Maybe it's going to restart on its own.
Environment. I think they've got 4 shards running right now. That's the last I heard.
4 shards.
And so
4 shards is pretty good.
When you deploy an account, as a developer, you think about what shard it goes to. The protocol decides where to put it. And then if an account gets particularly hot, like a CryptoKitties account, and starts consuming the capacity of a shard, then the protocol reserves the right to move that account to its own shard to isolate it so that the other accounts can take advantage of whatever the throughput capacity is. So
very interesting.
200 transactions a second is the upper bound. If you can have 2 transactions, but it'll almost certainly be lower than that for sophisticated transactions, I guess. So 200 TPS per shard is like the upper bound on that, and then it would scale, almost linearly per shard. This is. And so with here, you can think of it as like a multi-threaded system. Each shard is operating as its own thread, and then they get reconciled through consensus over time.
Yeah.
I guess the closest thing to that
I did a review of the Nightshade paper that they use for consensus in Near, and so if you want to learn more about that, it's on the channel. So.
Not a blockchain protocol. If I'm not making sense at this point, please forgive me. Transactions with Ethereum, you've got the idea of like a transfer, a contract deployment, and a function call. Contract deployment is like you send a transaction to a particular address, and then like the protocol knows that when you do that, it's going to take whatever the data payload is, turn that into a contract account that's generated from whatever your public key is on the gateway that made the transaction, incrementing nonce once you get this automatically generated contract address. There's a bunch of this like implicit stuff that happens in Ethereum with transactions. And so with Near, conversely, you've got these 8 basic actions, and you compose those into a transaction that you then send
source file.
And to deploy a contract, for example, you just make an account.
Oh, lots of errors.
You can make a single transaction that has create account action, deploy contract, add key, and invoke a method in one transaction. Do that all at once if you want as well. Those are choices that you make with those actions.
Some of these
scripts. These actions into a sensible transaction and set it, sign it, sends it an hour. Gas price, Ethereum is determined by network load and profit motive to make sure that people kind of keep the machine working the way you would expect. Whereas Near's gas prices is algorithmically controlled, so
I'm missing something clearly.
So the shard gets over congested and the gas price goes up at a maximum of
should I try it again, maybe?
per second, 1% per block, basically. This block is about 1 second. That's about how fast it will go up to try and disincentivize people from using the network. And if the congestion goes below 50%, then the gas price will drop at the same rate, 1% per second, 1% per block, to encourage use.
Okay, so they have some sort of VIP 1559 ideas going on.
Obviously, we're going to proof of stake soon, and there's a consensus at a rate of 1 per 15 seconds or minutes. I'm sorry, I forget right now. That seems to be still looking off the top of my head. And Near will also produce reports of stake consensus at a rate of 1 per second. So that's kind of like the high level of these primitives. In terms of some features, there's this kind of standard comparison. So ERC20 with fungible tokens, ERC721 with NFTs. The equivalent is NEP21 to match the ERC20, and then NEP4 to match the ERC721. And the differences in these NEPs, the idea is that we're taking advantage of the sharding mechanism and how accounts are used. So there's a few slight differences in the interfaces there, and some new proposals for improving on those as well are currently in process. For a transaction result, you check Etherscan on the Ethereum side. You just kind of look it up there. With Near, you can use Near Explorer, or you can use the CLI to check the transaction status by passing in hash.
Okay.
There's a couple of special data types, and I just kind of wanted to draw some parallels here. So with Ethereum, you've got the address type, you've got the mapping type.
Collections.
Ethereum, all accounts are string type, and so you can validate using a regex, basically, is valid account ID. And for mappings, we've got a set of collections. So this storage in Near's all key value pairs, and on top of that key value pair data structure, we've added some other abstractions, right? Like a deleted key or whatever. And so there's a bunch of those, and it's in blue in these slides. You can click on a link to get to it. And just to remind you, I posted already in the chat, but it's bit.ly/NEAR Meteor-102 to get to the slides. So any of these links you can click on, that'll take you right into the list of the collections in Rust or something.
I have the slides somewhere, but I'll put them in the description of this video.
Rust methods, and in AssemblyScript you just have to check to see is there some attached value, and if so, you might want to throw it.
There we go.
And then there's an event model in Ethereum where we don't have an event model in here, but you can poll this particular RPC method called experimental changes with the parameters, and that'll give you filtered log events, basically, to filter sense of what's happened on chain.
Okay.
And then to run a node, you would use something like an agent, like a CDR in Ethereum. With Near, there's a Near, it's a Python script that kind of manages whatever it needs to do in the background, and you just spinning up nodes and so on. And you can tell the nodes to run local net or testnet or
okay, cool.
Whatever.
So a lot of similar stuff you'd be expecting from developer environment.
Again, I'll just remind everybody, if you've got questions, you want me to stop or go back or something like that, just interrupt in the chat. If I don't hear from you, if I don't hear Heather interrupting you, I'm just going to assume that you want me to keep going. And then the pace is
keep on going. I have my speed turned up a bit, so if you want to slow down and watch the video yourself, I'm happy.
The idea is that you would compile this contract bytecode, compose a transaction, attach the bytecode, makes the initial value, sign and send the transaction to the special address that then creates the new account, plus the contract, then you get the new contract back. Right? So with Near, it's similar. You compile the bytecode and you compose this transaction, but the action that you use is deploy contracts. It's one of those 8 actions. You can also add things like create account with it if you don't already have an account that you're deploying to. You might want to add a key to allow you to control that account. You might want to transfer some value as well. You sign and send that transaction. You receive the outcome, basically. And then, of course, if you have a full access key, maybe I should say, of course, because you're just learning this stuff. Every Near account can have many keys. Like I mentioned that before. And the keys can be one of them. Full access, which basically lets you do everything, including send money, delete the account, deploy contracts. And a function called access key, which is constrained by budget, a set of methods, and a receiver. The receiver can be the account itself on which the key is set, or it can be a separate account that
This
you can
might be
use
why
as
I
a
have
proxy budget. So I can use a function called access key to spend a developer's money in like a trial basis to call a contract account that they've deployed. So you can use that for like a freemium model, for example, to onboard people without having to create an account and do all sorts of stuff.
It was result
anyway,
dependency tree.
These actions is the idea here. And then just kind of looking at this as a picture of Ethereum transactions, Near transactions. They all you can kind of think of them as having this metadata, attached value, like some kind of payload. So metadata maps nicely your origin.
I'll do it later.
VRS details from the signer. You can figure out who the signing account was. In Near, you actually have the signing account and the public keys included in the metadata of the transaction. Destination, Ethereum calls the recipient, Near calls receiver. Uniqueness, there's this idea of a nonce, and the nonce is really like a part of the key in Near. And then cost control, you would handle that through a function called access keys if you wanted to set limits and budgets. So that's part of the metadata in the Ethereum transaction. We simply get to press the limit. And then there's this idea of recency with the block hash, which is the proof of stake, is my understanding. So you have to include something from within the last window of time. That window is set at Genesis as a configurable kind of limit on how sort of proof of recency for the transaction. And I think it's set something like 4 hours or whatever it is, but you can look that up. It's just part of the Genesis configuration. And then value is basically just attached to either the native token in Ethereum and attached to your tokens in your protocol. So nothing really different there. And then in terms of the data, if, for example, we're making a function call, the data would include like a selector of the function signature or some prefix, I guess, first 4 bytes or whatever is the function signature, and then arguments encoded in some way. And then on Near, the actions are these 8 actions that break up into these 4 categories. So identity-related actions, like create account, delete account, security-related actions, add key, delete key. There's 2 kinds of keys: full access and function call access. Value for transferring and staking, where you can lock value up to maintain the integrity of the network.
Ooh, I staked yesterday for the first time.
So that's kind of the deal there.
8 actions.
A little bit more about each of those 8 actions. I'll just take a breath for a minute and let you read this slide.
Very interesting. I do want to do a video on staking soon as well, because I staked quickly last night, just off the cuff. But I wanted to dig into like who I was staking with, where's the money being used. It seems like the funds will be used to support women in blockchain, or women coding in some way. So.
Wait, was that a pun?
Coding in Ruby, I think.
Nice. Well played. Okay, so moving on, mapping concepts. So Ethereum and Near here, custom language, custom VM on Ethereum. So obviously the pros are like all this stuff is designed for the blockchain, so maybe you can formally verify. There's a bunch of good stuff there, and it's proven it's been around for years now, and it's managing a ton of value. The cons are you can't really reuse Solidity anywhere. You can't like bring in libraries from anywhere. It's just Solidity.
That's definitely tough.
Here you're dealing with assembly script and Rust, the WASM VM, and so some of the things that we talked about before, the tooling, the community, and obviously some cons is that it's not designed for blockchain. So like some things you can't do, like anything that reaches out to the machine, any libraries that sort of expect there to be a clock, for example, like that's not going to work. Or a file system, obviously that's not going to work. So it's a resource constrained environment on chain, so it's a little bit different that way. But it's kind of pros and cons here of some of these ideas, and then pros and cons just on Near of using assembly script versus Rust. For sure, if you're coming from the web dev world, like assembly script, it probably would take you like an afternoon to get to.
So I feel like if you were an Ethereum developer, it'd be easier to go through the assembly script language route because like JavaScript and Solidity relatively, I don't know. I feel like they're relatively similar, but.
To your heart's content, but the minute you're going to manage a significant amount of value, rewrite your contracts in Rust. It's the type safety and maturity of the pilot that gets you
type safety.
That safety basically.
Yeah. So
all right, so we can talk about some differences here. Because Near is sharded and accounts can be kind of moved around by the protocol to maintain maximum throughput across all shards, yada yada. There's this idea of like asynchronous calls. So
makes sense.
This is a view of asynchronous calls. I've been trying to figure out how to explain this best. So here's maybe like draft number 2 to try and explain this. The top half of this is what like stuff you already know as a developer. This doesn't do with Near. The bottom half, the internal stuff, is asynchronous calls from inside of your contract code. That's the new stuff. And I'm going to go top right counterclockwise, strange as that may seem, counterclockwise ABCD in order to explain these. Okay. On this picture here, we basically got external and internal batch and promise. So the promise is what you would see like if you look up like JavaScript promises on Mozilla Developer Network, like that's what that top right hand side is. And there's a similar thing in contracts where you can like make a call to another contract, you can fire and forget. It'll happen at some point. You can fire and register a callback to come knock on your door whenever that contract's done doing its thing. You can pass parameters.
It's good explaining this stuff.
Expect parameters to come back. Obviously structured types that you can set up those arguments whenever you're expecting the data to move back and forth. On the outside of Near, we call the payload of instructions a transaction. Once it passes the boundary of the network and it's happened inside, including these promises, we call it a receipt. And there's a term collision there in Ethereum because I think a receipt is like what you get back when a transaction gets processed. But in Near, a receipt is what you call a transaction. And once it's been kind of the signature's been verified, validated, the account's validated, it's got enough budget to actually do work.
I hate when these terms get mixed up, but
those receipts can kind of propagate around.
Receipt here is like a ledger of what happened correctly.
It can cause other receipts to be generated, et cetera, depending on these cross-contract calls.
Makes sense.
So that's A, is the promises that you know from JavaScript, and there's an equivalent inside of contracts that you can do that with. And then B, this idea of a batch, you can basically use the Near libraries to create a transaction, putting together a bunch of actions, these little yellow stickies inside the blue one, and then you can send that off to the network to be processed as a batch action. Internally, you can do that from a contract as well. Any of the 8 actions that are supported by the network, you can compose into a transaction and send that over the wire. I'll show you code right now. So here's what
code will help. Code will help.
A looks like this is just standard promises in JavaScript. This is moving now counterclockwise. B, this is how from the outside you would use our API to create a deploy contract transaction where you load a WASM file off the file system and then compose a function call action, calling some function with some arguments, attaching some value, gas in this case, and then you would push those onto the transaction, just an array, and then you would sign and send that transaction to some account on testnet in the last line there. So this is a batch action from the outside of the network. Inside the network, from inside of your contract code, you could create this contract promise batch. It's a mouthful, but it's basically this collection of actions that you can execute. And so you would say, make this batch for the account, the banana on testnet. I'm going to create the account, transfer some value, add a full action key.
Cool.
Related to mine if I'm the one who's signing the transaction that invokes this code.
Then
the sender public key. And then I want
Peel.
to create the account called Peel the Banana on testnet, transfer some money out of full access key, and deploy a
you
contract.
create Peel on the banana
transfer some money out of full access key, deploy the contract there. And so all of these things will be applied as
painful access. Create a new account.
Batches. So here's the transactions, this collection. Then I want to apply this other transaction.
Create a new account. Fund it.
And then the last one now, D, we're at the bottom right-hand side of that quadrant. I can call kind of a fire and forget, in this case, Peel the Banana. You using fingers as the method on the account, Peel the Banana.testnet, throw some gas in there to do parameters, and then quotes. And then maybe I want to eat the banana, using my face. This is the method on the eat the banana contract. Lots of gas, no parameters. And I can pass in a callback as well.
So you almost like a tree of contracts underneath yourself.
The promise, but from inside of the contract code. So
It seems. It's very interesting.
Coming from the Ethereum space in these models.
Yeah,
All right,
that's
so that's
new.
the end of the
That's
intro.
definitely new.
We can pause there and take like a.
Okay, I'm excited for what the questions are going to be.
Any comments, any concerns?
I think I have an issue with like not having assembly in Wasm. I haven't done much development on this new Mac Mini yet, so forgive me if I have to debug for the first few
If not,
videos.
we can just dive into the Rainbow Bridge.
There's a question here from Leandro. ETH2 is going to run on EWASM. Some features that you are presenting won't be native. Question mark. Also coding in AS or Rust.
I'm not sure I understand that question, and I don't know enough about ETH2 to say anything useful, frankly, so forgive me. I do know a lot of layer ones are using WASM as well and Rust, and so it's not an uncommon combination if that's where ETH2 is going, but I really can't speak in any meaningful way about that. In terms of assembly script of Rust, I'm not sure what that means. If you're talking about with ETH2, I have no idea. If you're talking about with Near, we support both. Assembly script is easier for JavaScript and TypeScript developers to get into. Rust is better for high-value contracts. I'm sure that you must mean something else about that last question. I just can't imagine what it is.
He says, okay.
Cool. All right, so Rainbow Bridge is this bridge, and just keep firing away questions. If there's something I'm missing or something else you want to follow up on, just keep asking. Be selfish with
Something
your
in the
requests,
hallway.
be generous with your support. If someone asks a question, I'm not answering it effectively. If you know something about it, dive into the chat and be generous there. That would help. So Rainbow Bridge is this connection between.
So this is where it starts getting fun. I'm going to slow it down now
This is a picture of what
because
it looks like.
now we're getting into things that are a little more complex, definitely new.
From the top to
And I might not even need the
and the two networks and all that kind of
oh wait, no.
parts. So at the top level, the sort of foundational layer of this, you can flip this whole thing over and call it like the base layer, but there is this pair of light clients that live on either network. So in Rust, written in Rust, is an Ethereum light client that has been deployed to Near Protocol. And that client sits there, it's a contract, listening for headers that are sent by some thing that's off-chain. You can imagine it's an Oracle, or it's a collection of virtuous servers run by community members cooperatively or maybe competitively somehow to try and get like the right kind of data into this light client, effectively headers from the Ethereum network. Okay, so we talk about trustlessness in that area there, but it's not part of the story. So there's some, maybe it's like a node program or a shell program, some script that's running this ETH to Near relay that's sending headers from the Ethereum network to this light client.
Okay, so Near can hear headers on Ethereum.
In written in Solidity, there's a Near light client sitting on the Ethereum network listening to a Near.
And they have a Near contract doing the same.
Those light clients.
So they have Near headers on Ethereum and Ethereum headers on Near. Cool.
On top of that, we have provers. And these provers right now are simple, but you can extend them. You can write other ones to prove other things. The Ethereum prover, the one written in Rust living on Near, is able to prove that an event
very cool
recorded on the Ethereum blockchain.
But I wonder what Near is using for this system, for this bridge. That's what really matters. How much money can you send over the bridge? How much value can you build in this bridge?
And basically say, yep, I see evidence that this event happened on Ethereum. It was recorded, I don't know, whatever time ago.
feel like hacking bridges is going to be like the next big like thing.
About transactions that have been processed by your
Sorry, the trucks are loud out there.
Has this transaction been processed by your protocol? Then your client finds proof of that and says, yeah, it has. All right. So from there, we can do things like build this particular use case where we have a token locker on Ethereum that lets you lock tokens, ERC20 tokens.
See, this is what seems really cool.
Fungible token contract on Near that lets you mint NEP21 equivalent to ERC20 tokens on the Near side. And so what you do is you lock up tokens on the Ethereum side. The relay sends evidence of that to the Ethereum light client
and
on
once
Near.
you've proved it,
The mintable fungible token
use it on Near.
Interrogates the prover. Hey, did these tokens actually get locked on Ethereum? And when they have been minted, it mints those tokens, the equivalent wrapped version of those on Near protocol. Okay. So here's an example of what that looks like.
Very cool.
So let's say we've got these rain tokens, and we say we're going to do that. We tell the token locker to take care of this. We confirm that we're going to transfer these tokens.
Okay.
Some locked event is emitted by the token locker. The prover verifies that, and then we wait. For
25 blocks. For 25 seconds.
Conservative bit there, a little fast forward.
Okay.
Value, we can wait longer, obviously, on the Near side.
Okay, so you can wait longer than 25.
Mintable fungible token to mint these things. We need a little deposit because the data to track that minting is going to cost money on Near, and then our tokens arrive on the Near side of the network. And we can reverse this by burning these wrapped tokens, and then they would be unlocked.
And then they would prove on the other side. Okay.
And it basically walks through this process, and then these blue bits of text are links directly into the code base where each of these things happens. Like
very cool.
Locking the token, emitting the locked event, waiting 25 blocks, etc. All the blue text there is basically available. Sorry, I didn't mean to kind of rush.
This is a great video. I'm going to be working on a Near Learning Center in CryptoVoxels probably. This video is amazing. This is so much explanation of how this works.
There's a bunch of sample code all open source.
Some water.
We just wrapped up a hackathon, or wrapping it up this week, I guess, to encourage people to play with this tech. And then here are those 4 steps that you saw earlier: 1, 2, 3, and 4 with some overlaps and activity diagram, I guess is what we call this. And there's all the different components there: the ETH node, the locker, the contract, and so on. So if this helps you kind of visualize what's going on, it's just a different perspective on that same thing. And then here are some of those repositories. So the example is this thing on the left, ERC20 to NEP21. And it's just github.com/Near.
Cool. So I can do this stuff too. Oh, this Near bridge.
Locally there. It might be a bit tricky to set up, but the docs should help you with that. Okay. And then on the right-hand side, we're just going to github.com/Near, and we query Rainbow to see the half a dozen repositories that are related to this bridge. Specifically, the CLI, Rainbow Bridge CLI, is what you would use to run the bridge, deploy contracts, things like that, get things set up. The token connector is a generic token connector across the bridge. It's not specific to Rain, like the example on the left here. It's a generic token connector that can be used for other things, and it's written in Rust mostly there. And then
this is really
RS and SOL are the 2 kind of sides of the Rust side would be like the Ethereum light client prover that runs on Near, and then the Solidity side would be the Near light client.
I want to read through the Solidity contracts for the prover and verifier. That's what I want to read through.
It's in JavaScript. So hopefully this gives you a good sense of how you can get started with the bridge. And then here's using the CLI, kind of getting started there. So the costs of running the bridge, it's expensive, is the simplest way to say it right now to run this thing. But we're working on that. So you get a sense of kind of the prices there. They're pretty high, and kind of get things working on the bridge. All right, so then maybe your question is, how do I get started with these toys? Here it is, create your app. We talked about that earlier. And you can actually do this right now if you want to follow along with
Okay, I'm going to try again.
So before I dig into that, any questions about
it? Because it sucks that it didn't work.
Comments about the bridge that you want to cover?
Maybe. Is it like that?
Nothing in the chat so
Then
far.
test.
Okay, yeah, no worries. I'll keep going. If you think of something, feel free to interrupt. So how do I get started?
It should
You create your app, just like create React app, it's create your app. And we talked about this earlier. Basically, depending on the things that you pick, you get one of these four generated.
Oops, should I have
right? So this is like a simple demo.
typed out more?
I recommend that you start with the default, which is going to be JavaScript. This is JavaScript on the far left. You can add some React to it if you prefer that. You can use Rust, the two on the right. Again, there's not too many different things here. I've highlighted in yellow some visual anchors so I can quickly scan
JavaScript and Rust.
Files that appears.
Okay.
The critical components.
Two high severity vulnerabilities.
You generate the project.
I don't want it. Usually it's fine.
And so here in step one, you can literally do this right now. If you've got Node installed, you can run npx, create your app banana, whatever your app is. You'll get this output here. You're on dev, you're on test, you're on deploy, just like npm.
Okay.
Or npm run test. And so, yarn dev or npm run dev is one of the scripts here.
Why doesn't it work?
Launch your project, get things kicked off, and then you'll see this appear.
See, yeah, I always have these simple projects with my lovely little Mac Mini. I probably don't have all the dependencies truly installed, even though it says that I do. Installing dependencies. Request promise, UX, resolve. And if this doesn't work, I might just try, npm audit fix to see if, okay, wait a minute. What? It didn't even attempt to work. No such file or directory. Open package.json. Oh, sorry. Let's package dot. Okay. So npm run dev. Where is it? Test version scripts. Okay. Builds. npm run build. npm run build web. Build contract. No. npm run builds. npm run builds. Dev. Will deploy contract near dev deploy. Deploy contract near deploy. npm run deploy. Let's see what happens there. I don't think that worked either. Yeah, no matter what I do, it's building something this time at least. Are you still going to open up? Because, if it just something different happens, that would be great. Nah, it was different, but I'm having an issue with the WASM, so I don't think maybe it's not the right path again. No such file directory, open this one. So this file needs to be open. I'll figure it out eventually. Probably tomorrow. I'm just going to screenshot that real quick because.
On the left, you click sign in, create an account, whatever it is on.
I'm actually just going to email Sharif right here and be like, I'm having more issues.
On the left-hand side, you're going to change the rating in the text box. Click save, and you'll see that updated little piece of toast, pop up and say, hey, your message has been changed on chain, and you'll actually be able to see that want to get a sense of how this stuff works, you can ask yourself, where are we setting?
It's funny, me and Amat, and then tomorrow when I meet with him again, it's going to be the exact same thing.
The word key store, and that'll take you right to the code where the connection is happening. Where do we log into the Air wallet? There's the hint to search for it, which lines of code, wire up the contract. There's the bit of code that you can search for to get right there. And then if you want to control stuff, you can kind of maybe mess around with this little challenge. But coming from an Ethereum background, this is probably trivial for you. So hopefully that gives you a sense of what's going on. And fundamentally, this is probably
near SDK assembly. Yeah.
But you're talking about contract
Rust.
development, UX development, right? So you can either develop contracts with established script or Rust, as we said, and then you're using near API JS. It's modeled similarly to Ethers JS, I think, is the inspiration.
Ooh, yay! Ethers JS is really easy to use. I like that.
And that just wraps the JSON and RPC API that we've got. And so that's your two kind of interfaces for development, extension, and presentation. Here's a picture from very high level. Your DApp on the left using this API to send and receive with the blockchain layer. Contracts written in assembly script or Rust that you deploy, they get loaded into this virtual machine, read and write to storage based on their execution, and then the response comes back. Here's what a life cycle looks like. Again, coming from an Ethereum background, most of this is probably a shrug for you, pretty obvious. And then there may be some interesting bits here where each account holds a contract and state. You can have
this is interesting.
one contract per account. And what you'll see is if you type at the command line near state and then an account name, you'll see this metadata come back, including the amount of value that the account is holding, a code hash that's all one.
Okay, wait. Let's see. That should be able to work. Okay, because I have. Okay. Oops. Let's do this again. Okay. And this might be too annoying to do on my ledger. If I continue doing this. Okay. But I like going through the process, reminding myself. Okay, so now, sorry, the video should be up. Terminal, and what did he say to click?
Including the amount of value that the account name. What you'll see is if you type a contract and state, you can have one and only one contract per account. What you'll see is if you type at the command line near state and then account name.
Near state and then account name. That should work. Near state Chloethedev .testnet. There you go. There's my amount. There's how much I have locked, how much storage I've used, how much storage I've paid for, I guess, or paid, I don't know, and the block height currently, and the block hash. And they were saying you can do something with the block hash. I can't remember, but that's, yeah.
You'll see this metadata come back, including the amount of value that the account is holding, a code hash that's all ones. There's no contract deployed to that.
Okay, so no contract deployed at that account.
Which is the SHA-256 digest encoded as TF8, I guess, if I remember correctly, whatever this code hash is, of the contract byte code.
Okay. So there's no contract, so it's all ones. And if there is a contract, it'll be the...
A contract has been deployed to it. And this fingerprint will always be the same for any given WASM file, any given byte code.
Makes sense.
So you can check whether or not an account has a specific contract deployed to it. We don't currently have deterministic compile on our contracts, but we're working on that. And so if you have the same already pre-compiled contract, you can redeploy it to multiple accounts and test because the fingerprint will be the same. If you recompile a contract from source, it may not necessarily generate the same fingerprint. Although I expect it's such a high priority feature that we should have that. And then for data, it's just key value pairs. In this case, encoded is base 64. And it doesn't have to be, but in this case it is. And then if you decode those, you'll find just key value pairs as you would expect. Some of the higher abstractions like the vector and DQ and NAP and stuff will have these kind of prefix structures where you pick up a letter or some text prefix for whatever the data is. And then for Rust contracts, there's this reserved keyword called state, where the contract code will actually live. And if you're having data that you're storing.
Oh, they give you a formatted amount? That's cool. That's cool. That's just something so obvious that should be included. That is, love that. Sorry.
And so near bindgen, you see is this attribute or
bindgen
or whatever for this posted message class. There's this is for the guestbook example. There's whether or not it's premium is a boolean, sender string.
It's way harder in Rust. My lord. Okay, I'm gonna pause this because this looks completely like okay. So in assembly script, it looks pretty like everything looks like it makes sense. Import context, U12B, persistent vector from near SDK assembly script. So you're importing stuff, libraries, I guess, from the assembly script. Exporting a new class posted message so it can be used outside of this file. So near bindgen, export class posted message. Premium, Boolean, sender, string. Remember the sender there's always a counts for all strings here. Constructor, public text string. So I guess it's going to return an account, I would assume. And this account, I would assume, dot premium equals context dot attached deposit is greater or equal. Oh, my back. To U12B dot from a big, 1, I'm assuming, if it's to the power of 18, 10 to the power of 18. This dot sender equals context dot sender. But the side for Rust looks so confusing. Oh, environment is your account.
That decides whether or not it's premium. You capture the sender as well from the context. And then here's kind of the similar equivalent in Rust, basically on the right-hand side. So near bindgen, you've got some serialization there for putting data on chain.
Okay.
Your struct. And then this method of creating.
Why are you adding the text string? New text string self, okay.
New message in the same tests. In the behavior side,
that whole imply guest book here and stuff is going to confuse me.
Message, we make a new posted message and then we push so that
it looks completely different.
My understanding is that
looks completely different.
Any variable assignment that you do in Ethereum gets recorded on chain.
Two implementations, near bindgen, near derived default, or serialized, to get the code on chain.
Generally, when you assign a variable,
struct guest book,
contract that gets recorded on chain. It's not so
vector.
Near. You have to explicitly call storage set, storage write. That's happening inside of the persistent vector class here. It's basically calling that. If you look at the source code, somewhere it'll be like a storage set or storage write.
Okay.
And so the posted message again is even higher than that because it's our custom domain object that we've made that represents the message.
Okay.
And so you're not going to see any kind of writes here, but whenever you push this message on the messages underneath the hood, that's getting written to the chain.
Okay.
Get message, kind of reading this back and returning this collection of posted messages. Again, the same thing here in Rust.
Actually, that was confusing. The whole export messages start index thing.
Let's see. You can add a message and get a message here. And you'll have to forgive me, I wrote this, but didn't test the Rust side of this code. So if you find a bug in the Rust side of the code, that's on me. No matter what, the output is always a WASM file, and with assembly script, you can actually, the WASM is...
I've never looked into WASM much in my life, so WebAssembly, yeah. So I need to for like ETH2 and eWASM, but
WebAssembly is text.
Haven't got there yet.
This other representation, it looks like a kind of a lisp, I guess, and you can see a bunch of the names of these tokens, like get message, functions, add message, get messages, right in the code, and you can practically read the WAT format to see what's happening on the stack here, getting things, pushing them on stack, popping them off, etc. So that's the WAT format. And with assembly script contracts, because the compiler is so close to the
this is a great educational video that is really learning center though. Gosh.
Files are much more readable. With Rust, there's a lot of machinery. It's going to be hard to read the WAT file like this. And then we could walk through the guest book, but I think we're close to running out of time here with 8 minutes. So I'll just continue unless I'm interrupted by questions. So again, the guest book, a couple of main folders, assembly and source. And here's the data model. So post the message, you've seen this. Here's a little bit more explanation of what that looks like.
Uint
Just let me
128.
read this.
So it's like, and whenever I write in Solidity, I'm usually just only using Uint 256.
And you have access to the slides as well.
But I always like seeing in different languages when you like when to use different like uints and different numbers. But I guess in Solidity, you're always assuming, okay, if this contract's here forever, you want to make sure that with the math, you never overflow or underflow. So use a big number and use the storage. But
and then the front end. So here we're connecting to Near, wiring up the contract, we get this object, JavaScript object.
I hate front end stuff. Like, sorry, JavaScript. I studied it a bit for like Solidity development, but like, it's relatively easy to understand though, which I like.
Loads this up. This is the React version. Using some
Wallet.request sign in, wallet.sign up.
The wallet handles the redirection to the wallet back and forth. Your private key stored in your local storage. And then a little bit more.
For testing it, I should probably open up. I think I'll be able to do
resolving and
add account.
So if you add a message, kind of the page refreshes. Okay, so that's the end of the presentation. We have about 5 minutes left for questions or comments or corrections. Wide open for feedback on this stuff. This is not
okay.
Not all in my comfort zone. Maybe a half.
Interesting.
If I wanted to be ambitious, but this is stuff that I'm very comfortable with. But there's a lot I said here tonight that I would appreciate your critical feedback on. Slides are at bit.ly/near-102.
There's slides as well.
Is where you can
a lot of good information. I need to, again, obviously figure out why I'm unable to. Obviously, I can start poking into accounts and poking into these with the Near CLI now, which is awesome.
There's a couple of.
But what stinks is that I'm having some issues with the WASM or whatever. So, but I will message Sharif and I will figure that one out. Any more questions?
Trying this. Thank you, Sharif. And thank you from everyone at Eats Global. This is a great presentation.
Awesome. Well, that's the end of that video. Thanks, Eats Global. Thanks, Near. So yeah, that's pretty much for that. Obviously, it didn't work. I wasn't even planning on trying to code it. I'm glad that I did pull out my terminal, and I'm glad I had the issue with trying to code again. Because yesterday when I had the issue, you can go back and watch me. I was quite discouraged. But this time I'm still smiling, still good, because I'm sure it's another silly issue on my end. If anything, I'm more discouraged about not coding on Linux. Whenever I'm on Linux, everything just works. I click a button, everything. Well, not everything. I've had a lot of problems with my Ubuntu server right now. Speaking of, I need to get on that. But I'm going to hop off now. The WIP is at 3. I'm going to be going live for the meetup there. It should be fun. Probably going to have some lunch until then, but not sure. This video was just me watching this. I know I interrupted a bit. I know I talked over it. So if developing on Near seemed interesting to you, please watch the video yourself. The slides are in the video and in the presentation. If you have any questions, concerns, comments about developing on Near, if you think you want to maybe try using the bridge or anything, I might not be an expert on this stuff, but I could, try and ask someone who might know more information or point me in the right direction. So yeah, that's all from me, Chloethedev. Hope everyone here has a wonderful day. And, if you want to come to the WIP meetup in CryptoVoxels, I wouldn't even know where to get the information. Go on Twitter, type in WIP meetup maybe, and like Razzle or something.